Alpha technology is a homogeneous bead-based assay format which is read in microplates that requires no wash steps. The first step is to add the sample containing the target molecule. Only a small amount of sample is required, just 5 microliters in standard assays and less than 1 microliter in miniaturized assays. Next, add biotinylated antibody and acceptor beads coupled with a second antibody. The analyte is captured by the antibody pair to create a sandwich assay. During an incubation time of around 60 minutes, the biotinylated antibody binds to an epitope on the analyte of interest. The second antibody binds to a different epitope. Next, the streptavidin-coated donor beads are added. The streptavidin-biotin interaction pulls the complex together, bringing the 2 beads into close proximity. It is possible for multiple binding interactions between the beads, which strengthens relatively weak interactions. Unlike typical wash-based assays such as ELISA, electrochemiluminescence, and flow cytometry assays, there are no wash steps required. This preserves biological interactions that can be disrupted by washing. After another short incubation, the assay plate is read. Alpha technology can be read by the Perkin-Elmer Envision or Inspire Alpha readers. They have highly sensitive laser detection modules allowing for unprecedented sensitivity. Alpha technology is also easily automatable using the Janus Automated Workstation System. The alpha plate is loaded into the reader and the donor beads are excited by a laser at 680 nanometers. The excitation causes a release of singlet oxygen molecules. Each bead can release up to 60,000 singlet oxygen molecules, which acts as an amplification step, making the assay very sensitive. The singlet oxygen molecules can travel up to 200 nanometers in solution in comparison to TR-FRET type assays, which only allow a 9 nanometer space between donor and acceptor. Therefore, alpha technology can analyze very large complex molecules and interactions up to 20 times larger than TR-FRET. The singlet oxygen initiates a cascade of reactions inside the acceptor bead, resulting in a light emission at 615 nanometers. The emission wavelength is shorter than the excitation, meaning there is reduced background interference. Only the acceptor beads that have been brought into close proximity are excited. The higher the concentration of your analyte in your assay, the more bead complexes are brought together, resulting in a signal intensity that is proportional to the concentration of the analyte in the microplate well. The beads are very small and suspend in solution, unlike most bead-based technologies that can clog tips and require constant vortexing.